In this section, we're going to review over the functionalities provided by Java in terms of a linked stack ADT. The section in this book is a little bit short, it's just a couple pages. So what I decided we'll do is we'll actually go through one of the problems from the back. So we're going to do problem 13.5. So I've already typed it up. Design and implement an application that reads a sentence from the user and prints out the sentence with the characters of each word backwards. Use a stack to reverse the characters. So this is kind of an archetypal problem in terms of learning stacks, right? We're just going to use a stack to reverse all the characters in a word. And instead of kind of using our own homegrown one, right? That's what we'll do later in this chapter is actually create an entire link-based stack from scratch. We're going to use the Java API. So let's go ahead and get started with this. So I'm going to first copy this text. I'm going to put it over here in my BlueJ. So I already have this kind of base file that I've already put together. So what I have here is my public class PP13.5, right? So this is where I'm going to be working for this section. And then I already have in here kind of our main, right? And right now it's just blank. So we're going to kind of proceed in the same way as we've done for previous programming problems and try to break it down a little bit. So let me go ahead and come up here. I'm going to copy this and let me paste it down to my main, right? And then we can read through the text again and try to identify what are the small parts of it that I could kind of try to work with, right? Rather than worry about everything at once, what are the pieces that go together, right? Identify those, try to address them, and eventually we get kind of our whole thing. So let's see. Let's go ahead and kind of delete out this first text. This doesn't really matter. So our goal here, right? Read a sentence from the user and print the sentence again with the characters of each word backwards. So over here, I also have kind of the second requirement, right? Use a stack to reverse the characters. We'll come back to that in a second. Let's see, how can we break this down? This is really two parts of a problem, right? One is to read a sentence, the other is to print it out with the words in reverse. So we can actually kind of break this apart, right? So I know I'm going to have one part of my program that reads in a sentence, and then another part that prints it out with the characters of each word backwards. Perhaps there's another part we could break in here. So what if we did this? We said, okay, print out the sentence with the characters of each word backwards. Well, the characters of each word backwards, that kind of sounds like a little bit of a functionality, right? Imagine you're printing out a sentence, and then at some point, right as you're going through it, you need the ability to reverse the letters in each of those words. Well, maybe that could be something like a method. So let me actually kind of break this here, right? I'm going to put this on its own line, right? So this is part of this half of the entire problem. So we want to print out the sentence again, but then inside of that, right, is the problem of getting those words and reversing the characters in them so they're backwards. And then really part of that, right, is this here, right? Use a stack to reverse the characters. So this is kind of the base of my problem, right? I need to first read something, and then I need to print it out again. But then for each kind of word in that sentence that I've read in, I need to reverse it, right? So there's essentially three things for me to work on here, right? Reading it in, printing it out, and reversing the parts of it. So I have three different things I need to do. So let's go ahead and just start from the top. So the first thing I want to do is read a sentence from the user. Well, if we want to get input from the user, that typically means we need to get scanner, right? So let me go ahead and bring in a package, right? So let me import scanner so we can do that. So let's go java.util.scanner. So that'll bring in the scanner object, right? And then we need to actually create one. We just have the scanner class available. Now we need to actually create an object. So now we can go, let's say scanner, scan, which is kind of our standard name, equal new scan, right? And then into that, we'll put the parameter system.in, right? We're reading in information from the user, right? We want to get a sentence from them. And then I can go ahead and maybe let's say we go ahead and prompt the user, right? So imagine the user's running a program. We want them to give us a sentence to reverse. Let's ask them for it. So let's go ahead and put in a println. And we'll just say, please enter a sentence. So now they know what we're asking for. And then the next thing we need to do is go to the scanner and get a line of text. Well, that line of text, I'm going to need some place to store it. So let me go up a little bit and let's put in another variable. So let's put in a string variable that'll store the text that the user enters. So now we have a variable. Here, right, we didn't need to initialize it to anything because I'm going to read in text, right? I don't need to set it equal to something because we're going to get whatever should be stored in there. So over here, right, I can go down and let's actually populate it now, right? So let's put some information inside of that variable. So here we want to get the information from the scanner, so I'll do scan dot next line, right? Here I'm just getting a line of text, right? I'm not getting an integer, I'm not getting a double, I'm just getting text. So this is going to be what I need. So as a whole, right, this bit of stuff right here is just doing the read a sentence from the user part, right? So after this code has been executed, right after all this stuff happens, at this point I've now read in that sentence and I'm good to process it. So the first part of our problem is already done. So what about the next part? We want to print out the sentence with the characters of each word backwards. If you remember a few minutes ago, one thing I can mention doing is maybe encapsulating this or putting this into a method, right? You could imagine creating a method that would take in a word and then returns it with all the letters or characters inside of it backwards. So let's say we do that, right? Let's essentially take out this functionality and put it into its own method, right? We want to kind of break our problem into smaller pieces. So let's go ahead and try typing this in. Let's actually, what we'll do is actually write a method signature, right? We'll make kind of a dummy method, one that's not complete. And then once we kind of have that available, we'll jump back up and finish that prints the sentence with blah, 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 right? We'll complete that main loop, right? And then the last thing we'll do is come back and do the reversal. So over here, right, we're going to say, okay, I know I'm going to need a method that does this character reversal, so let me go ahead and do that. So we'll go over here and we'll do public, right, static, because I don't have really a class here. And then the return type will need to be string, right? I want to have a method that takes a string and then gives it back to me, right, where the letters have been reversed. And we'll just say, let's go for reverse word, right? That'll be the name of our method. And then it's got to take the one parameter, right? Some string to reverse. And I'll just call it str. So let's do this. So I'm just putting in my curlies there, right? So I have something that'll compile. And then what I want to do is right now, because I don't want to complete it, right? I want to finish kind of that main method first. I'm going to put in here kind of a little stub. So let's put in over here, should be reversed, right? So instead of actually doing anything, this method is just going to return this little word here, right? It says, yeah, obviously you're not done, right? This should be reversed. So this is kind of a temporary placeholder so that we can use this method, right, up here when I want to do this, print the sentence again. Then once we kind of have that working by itself, right, once we can print out the sentence again, then we'll jump back here and finish doing the reverse method. Real quick, let me click compile. Okay, so everything looks good. Let's look back up at doing this print the sentence again, right, with everything reversed. So let's think for a minute about what the user enters. Well, the user is being asked to enter a whole sentence. So basically what that's going to mean is that the user is going to type in a word, some spaces, another word, some more spaces. Well, if that's the case, right, what I want to do is read through all of the words in that sentence, right? I want to look at each one of those, and then I want to print out each of them reversed. And then once I've printed out them reversed, I probably need to put the spacing back in, right? I don't want to have everything kind of crammed together. I want to first act on just the words, but then once I've kind of reversed them, and before I print them out again, I need to make sure that spacing's back in there. So what we can do is something we've seen in a couple other problems, which is going to first be to use scanner to take that input sentence and break it into different chunks, right? Break it into different tokens. Because what we want to do is we want to look at each word in that sentence by itself, right? Look at each one, reverse it, then print it out. So over here, what we'll do is we'll actually create another scanner variable. So what we want is something that's going to break up our text, right? So this scanner, we're going to have kind of similar to the last one, right? Scanner equal new scanner. Well, we should change the name of that variable, right? We're not allowed to use the same variable name twice. Let me name that parser, right? So it's going to be something that parses through our text. But the other major difference then, right, is over here. We're going to do parameter, right, going to the constructor of scanner as actually being that piece of text, right? So this scanner is created with the text inside of it. So this scanner is actually going to take on the task, right, of processing this text and splitting it up based on where the spaces are. So in here, what I'm going to do is I'm going to put in a while loop. And this actually goes back to when we were using iterators a while ago. We're going to iterate through the different words contained in this string and then try to reverse each of them. So what I'm going to do over here is I'm going to do parser dot has next, right? So this is my condition that says, oh, how long do I do this loop for? Well, I want to keep on looping while there's words in that input, right? The user gave me some sentence, and the parser is going to break up that sentence into different words. Well, I want to keep on looping on that, right? Processing each word in turn, as long as there's still words in there, right? So just continue while the parser still has something, to come. So inside here, I can think of it as, oh, right now the parser is giving me each word in turn. Let me create a new variable to actually get the word from the parser, right? The parser is going to have everything inside of it, but really I want to have a variable that stores it by itself. So we'll just call this word. So string word equal parser dot next, right? So go into the parser, grab out the next element. And then what I can do over here, right? I've taken out a word from my sentence, right? And it's going to visit all of them, right? Because I'm in a loop. Is go ahead and actually print it out. So if I want to print it out, I need to go back to doing a println. So let's go ahead and put that in there. System.out.println. And right now, right, if I just did something like this, right, system.out.println of word, well, then nothing would really happen, right? It would break up everything, but it wouldn't reverse it. Let's actually try that really quick. Let's see, cannot find symbol scanner. It looks like I have a little typo there. I have 3 N's instead of 2. Let's remove that. Okay, so now it compiles. Let's try running this. Hopefully it'll prompt me for some text, and then I'll enter it, and then it'll print all those words back to me, right? We're not done yet, right? But it should at least be printing them back to me. So let's go ahead and run this, and let me just type in, this is a test. And it looks like everything's working so far. We entered in this text, and then notice it printed back each of those words, right? So that while loop, right, it's looking at each of these words in turn, right? First it's looking at this, and it's looking at is, and it's looking at and then it's looking at test, right? So it's looking at each part of that sentence, right? So that's one of our things we want to do, right? We need to break up that sentence so we can go and then reverse each of the words. Well, right now we're not done reversing the words, so it's just showing them broken up. Maybe one thing we want to think about is that in the future we want this to all be on one line, but we can kind of come back to that. For now, let's just go ahead and start with the reverse, right? So let's see if we can use a stack to reverse these words, right, and kind of get what the output is looking for. The first thing I want to do is actually jump back over to that println. Right now we were just printing out word again, but really what we should have there is a call to the method, right? So we decided earlier that we would write a separate method called reverse word that takes in a word, reverses it, and returns it. Right now we're not using it though, so we need to kind of update our code over here, so we are. So let's go into the println, and what I'm going to do is I'm going to change this into a function call, right? So now instead of just doing word, we're doing reverse word of word, right? So that's now a parameter, right? Now we're processing that word. And let's actually go ahead and compile and run this again. So hopefully if we do this, right, we're going to get back kind of the same prompt again, but when I enter in my text and then it goes to display it again, it'll actually display should be reversed a whole bunch of times, right? Because right now that reverse word method, we haven't implemented it yet. So right now it just has this kind of temporary text in there to remind us that it's not done. So that should replace all the words we have over here on our left side right now. So let's go ahead and do this. Let's do this is a test. And here, this is what we were expecting again. So here you notice we have the should be reversed. It's being displayed 4 times because that loop, right? That loop is calling reverse word 4 times because there's 4 words in that sentence. But right now, since the method isn't done, it's just returning that little FY that says, oh, this isn't done yet. So that right now, it looks like that's working. Why don't we actually go ahead and put in the spacing again, right? So right now, all the words are on different lines. But in the end, right, what we want to do is essentially have that same sentence all printed out in one line again with spaces between each of them. So what I need to do is go over here, and I'm going to change this from println, right, print with a new line, to just print by itself, right? So now all these things will be on their own line. And then after that, what I need to do is add in a space, right? So if I don't have this here, right, and this is essentially adding a space after the text that's being printed out, all these things will be on the same line, but they'll be crammed together, right? They'll be back to back. There won't be any spacing. Here I'm manually including the spacing. And let me actually go down here. Let's make it maybe look a little bit fancy. Well, it's not going to be fancy, but it's going to be better for us. We're going to put in our blank line later, right? Because all of this stuff here is going to print out on the same line. But we do kind of want to finish it out, right? We want to move down to the next line after we're done displaying stuff. So in order to do that, I'm going to add in one kind of blank println here at the very end that'll kind of finish it off, right? It'll say, okay, this line is done, jump down to the next line. So now if I compile this and run it, I should get everything. I should get all those still the should be reverse text, but they should all be on one line now, right? And there should still be 4 of them. So let's try this. And that's what we get, right? So now we're back to one line, and we have our little strings in there, and then they're all separated by a space. So that looks good. So the only thing I really need to do now in order to finish solving this problem is to implement this method, right? So our goal, right, was to break this problem into pieces and actually be able to test each part of it. We've verified that our reading works and then our printing of the sentence works right. All we really need to do is finish up this reverse word method, and then we're good, right? We don't have to worry about everything at once. We're just going to focus on this one method. So what do we need to do? Well, the first thing we need to do is be careful, right? We had kind of an additional requirement in here that told us how we were supposed to do the reversal. And the requirement was that we use a stack, right? So this is where we're going to need a Java API. So we're going to use a Java API to create a stack, and then we'll do that and then we'll use that to actually do the reversal. So I'm going to start by typing out our line, and then I'll explain what it does. It's going to be a little bit complicated. It's not going to be as straightforward as we would hope it will be. But let me type this out, and then we can talk about it. So let's look at perhaps the easy part of this line first, which is this over here. Notice we have little arrows there to indicate generics, right? So this is something we've seen with a lot of ADTs, just to indicate that, hey, this thing can be set up with whatever type you want, right? And here, what we really want to do is have a stack that stores characters, right? Character is the thing inside the arrows here, right? This is my generic type, right? This is the thing I actually want to store, not just some T that I don't really know what it's going to be. I want to store characters. And hopefully that makes a little bit of sense to you, because strings are made out of characters, right? And we want to take a string, break it into different characters, right? And then have them become reversed, right? We want to put them into their reverse order. But we want to break it up by character. So that's what we're going to need to store in our stack. The rest of this line is probably not so clear. So there's two things happening here. First, we have something called a DQ, or some people use the term dec. And then over here we have something called a linked list. So the first thing to worry about is this here, the DQ. So a DQ is actually an interface in Java. It actually stands for something called a kind of a double-ended queue. So it has the functionality of a queue, but essentially everything's available on both sides, right? You can add or remove from both sides of that data structure. But this is just an interface, right? It's not actually a class, it's just an interface. So the reason we're going to use this here is because this is actually what's closest in Java to an actual stack. There is a full kind of a stack implementation in Java, but the issue is there's kind of some odd stuff in how it was implemented, as well as what are the methods that are available from it. So instead of using that thing that's actually namestack, we're going to use the DQ interface, right? And the DQ interface is going to include the standard push and pop functionality for a stack, but it provides some other stuff as well, right? It's for a DQ, right? It gives us more information, but we're going to act as if it's a stack, just because this is kind of the best way, or I should say the most pure way to access stack functionality inside of Java. Now, since this is an interface, there's a bunch of different classes that actually implement it. One of the ones that implements it is a linked list, right? So this is Java's implementation of a linked structure, right? This is the thing that contains a bunch of nodes, right? And they're all linked together, right? And we can easily add or remove from it. This is the built-in Java implementation for that. And they just call theirs linked list. Since linked list is actually going to be implementing that DQ interface, we can actually take this linked list object, right? We're requesting a linked list of characters, and then we can store that into the stack variable, right? And the stack variable is of type DQ of characters, right? But because this is implementing this, right, this class implements this interface, we can do this kind of storing this thing into the stack variable. And so going forward, what we'll do is we're just going to pretend that stack interface, that stack variable, isn't actually a DQ. We'll just treat it as if it's a stack, right? So we're going to use push and pop and maybe peek if we need it. We're not going to touch the other stuff in that. So this to me is very much, it's a limitation of the Java API, right? Just because Java doesn't include a very good linked stack implementation for us to use. So we have to go this route instead. So at this point, we've created a stack. But maybe you're not quite sure how we're going to use that to reverse characters in a word. Well, here's a simple idea. Imagine that we take apart a string, right? So we want to look at every kind of letter in turn, right? So let's say over here, right? If we're looking at the word this, we'd first look at T, then H, then I, then S, right? Imagine we're going to look at each of those letters in turn using something like a loop. Well, if you did that, you can imagine putting them all onto a stack, right? So T would be the first thing, then on top of that would be H, then I, then S. So we'd have our stack filled up with all these letters, but things aren't quite reversed yet. Well, if you think about it, what you could do is start popping them off, right? So if you did a pop on that stack with that word this in it, the first thing you get back is an S, right? And then if you did another pop, you get an I, and then an H, and then a T, right? So if we actually pop everything off and append it to what we already got, right, then we can actually have the reverse of that string, right? We're going to reassemble those characters in a backwards order. So that's the approach we're going to use here, right? We're going to populate the stack with stuff, and then we're going to pop it all off and concatenate it back together. And that'll give us a reverse string. So over here, the first thing I'm going to need to do is actually put everything onto that stack. So what I want to do is loop over every character in that input string and do a push on it. So let's start by putting in a for loop that can look at every single character in that string. So let's see. I'm going to type in 4, and I'm going to go int I equals 0, right? So starting at the first letter in there, right? What I want to do is I'm this loop where I was touching every letter. So the first letter is at essentially index 0, and the last one is at index length -1. For the second part, then I'll put in that requirement. So I'm going to go I less than string dot length, right? So go up until the length of that string. So that's my start and my finish. Every time I loop, right, I want to do an increment, right? I want to move up by 1 index, right? I want to see the next thing over. And I put in my curlies there. So now at this point, I need to go and actually add that particular character from the string to the stack. So what I'll do is I'll start by doing stack.push, right? I want to add in a new element. And then from there, right, I can go into my string and get a character out of it. So we're going to go str, right, the name of the thing that's being brought in as a parameter, and then I'm going to use char at, right? So char at is a helper method inside of the string class that lets me get a particular character from a string. You can think of it as kind of acting like the bracket notation for an array. To that method, what I'm going to do is I'm going to pass in I, right? So we're saying, okay, get me the ith character from the string, right? That's what this text here is saying, right? Get me the ith character from the string, and then take that character and add it to the stack. Actually, right, I kind of made a huge typo here. This should really be push, not pop, right? We want to add stuff. So if we have this, right, we should be taking that character, taking all those characters in turn and putting them on the stack. Let's try compiling this really quick, and we should get an error. Cannot find symbol, class DQ. So these two are kind of extra bits of functionality, right? DQ and linked list. So we're going to need to do the same thing as we did for scanner, which is add some imports to bring those classes into our program. So jumping back up top, the first thing I'm going to do is bring in the DQ. So I'm going to go java.util.dq. So that'll get us that interface that we're going to treat as if it's a stack. And then let me bring in the linked list. And again, this will be a java util linked list. So that should bring me in those two things I need. Let's do a compile, and now everything looks good. Now that I have all the characters from the string in my stack, I need to pop them out and add them to a new string, right? The reverse string. So let's go ahead and do that. So let's see. The first thing I need to do is create a new variable, right? I want to have some place that I can actually store that newly reversed string, right? So let's go ahead here, create a new variable type string, and I'll just call it reverse. And I'm actually going to initialize this here to be an empty string. And that'll kind of make my code a little bit easier later, right? To just say, okay, initially the reverse is empty. And then over here, right, I'm going to go down, I'm going to start another for loop. Actually, it'll be easier if we do a while loop. Here, right, we're not actually going to have to loop and look at every character in the string, right? We're actually going to be able to loop over the stack. We're going to be able to process the stack while there's still something there, right? While it's not empty, right? So we're actually going to go over here and do while not stack.isEmpty, right? So our stack, right, that's going to be storing every character in my string, and what I'm going to do is I'm going to be popping those out and adding them into reverse. Well, if I'm popping them out, right, if I'm actually removing them, right, I'm not just doing a peek, the stack is actually becoming smaller each time. Well, what I can do then is have this while loop that keeps on going, right, keeps on popping things off until there's nothing left, right, and that'll be my exit condition, right. I'm done processing this string, and I should be good to go. So in here, what I'll want to do is pop off a character and add to that reverse string. So let's go over here. We'll go reverse plus equal stack.pop, right. So take off a character from that stack, right, whatever is the topmost thing, and then add it to the back of the reverse variable. So this should give us the process, right, of essentially reassembling that reverse string, right. First we were populating the stack with all the characters. Now we're removing all of them and putting them into a string that has that reverse ordering. The last thing we need to change here, though, is this return variable. So instead of returning should be reversed, we can actually return something useful, right? So now we can return reverse because now we've filled it out with the data that came in from that string. So if we go and compile this, it should work now. So now it compiles, and let's try this again, right? So let's go ahead and go void main, run this, and let's type in this is the test. And you're going to actually see, I think it'll reverse the period, right? Because the period is actually being treated as part of that word containing test. So hopefully, right, we get this entire thing, and each word, right, is still kind of in its original position, right? So the first word is going to be this, but in the output, right, it'll be reversed, right? So it should be SIH uppercase T. So let's see if we get that. And there we go. So you can see here that all the words are still in order, right? This is still the word this is still is, this is still a, this is still test dot. But now, right, each of these words, the letters in it have been reversed. So that about wraps it up for this video. Again, the kind of the key point here is to see how Java's stack implementation is working, right? So for the most part, it works exactly like the standard interface we're going to be implementing later on, right? We still have this push and pop, right? That's what we had actually in the stack ADT from the last chapter. But instead, they're actually coming from the Java implementation of it, right? So that was over here us using that DQ with the linked list inside, right? So it was a linked list object, and we stored it into a DQ variable. And that DQ variable gave us a standard list functionality. Push, pop, is empty, and it also includes peek.